and all. So we are continuously upgrading our knowledge with all field discussions, field meetings, etc. Now talking about Hptlc, what its P stands for? It is always stands for performance, high performance thin layer chromatography. Okay, P is not stands for pressure at all. Huh? There is no role of any pressure involved in Hptlc system. It is not high pressure thin layer chromatography. It is always high performance thin layer chromatography. Okay. So the basic principle of Hptlc is based on normal TLC. You know the principle of normal TLC? What is the principle? Adsorption. It is adsorption chromatography, and most of the time normal phase chromatography. Okay. So before starting, you are all from postgraduate, means MSc forensic science. That is great. Means jack of all, master of forensic. Is jack of chemistry, biology, everything, zoology. So that is very important. So in this field, forensic and chemical sciences and all, chromatography plays a vital role. Before starting Hptlc, what is chromatography?
Separation of components.
Separation of components of mixture. We want to separate components from its mixture. So that is our main motto behind any chromatographic analysis. HPLC, GC, GCMA, TLC, HPTLC, paper chromatography. Behind that main motto is separation. It is separation science. Okay, chromatography is separation science. We are separating components of mixture. So generally mixtures will be from any field, like visceral samples or any charas, ganja, afim, hashish oil, etc. samples. From that we have to separate different cannabinoids or tetrahydrocannabinoids, CBN, CBD, etc. Or explosives mixture, like any sample from blast site or something. From that we want to find out whether the blast is because of TNT, RDS, tetrine, etc. The region of the bomb blast. Okay. Or sample from any herbal field, like if Nerium oleander contains one poison, if someone died because of that poison, in their post-mortem sample we can find that poison. Toxicology, in toxicology department. So sample will be from any field. Sample will be complex or simple. Okay, simple samples, just example of any simple sample, any tablet. If you take paracetamol tablet, it is having weight nearly 600 mg or 700 mg, containing 500 mg of paracetamol, 200 mg, depend on label claim. So it is comparatively simple sample matrix. There is only one analyte which is in very high quantity present in our sample, and we can separate it properly. We can assay it. Assay कर सकते हो उसका. हाँ? So there are two again categories, like trace analysis as well as assay analysis. So in trace analysis, sample preparation, sample matrix plays vital role. So why I am talking all these things? Because Hptlc is very fast, rapid, cost-effective technique, and we can load any sample matrix, complex or simple sample matrix, on Hptlc plate, because it is visual chromatography. After sample application on TLC or Hptlc plate, we can see what exactly happening, how separation is going on our plate during the chromatographic analysis. So whether that is possible in GC or HPLC or any other technique, no. Mostly we are using closed packed columns for separation. So in that case, after whatever sample components coming out from that column and passing in front of a detector, then only we comes to know what exactly happening, what happened, and which components are there. But in TLC, HPTLC analysis, we can actually visualize whatever going on our plate. Yes. If you have any doubt, please, I request you to note down, or you can interrupt me anytime, ma'am, sir. You can ask that doubt, so we will clarify. It is not like one-way communication. It should be interactive also, fruitful to you also, because
I'm only just wondering,
how your unit or how your equipment stands out compared to others? What is the unique feature in this? I mean,
Yes, yes.
HPTLC everybody knows, but then how your firm or company stands out when
Yes.
compared to others? What are the unique features and
Yes, yes.
edge? What is the edge you have over other companies?
Yes, yes, yes. Actually, in the field of Hptlc, you can see this evolution since 1960. And ma'am, before that, Camag is the only manufacturer of Hptlc systems updated with latest software. Nearly 95% of the market stake is from Camag itself. So, across the world, you can see 95% setups from Camag HPTLC systems. And in India, we are the only distributor of Camag HPTLC system. Anchrom is the only distributor. If you want to purchase something from Camag, it is through us, Anchrom. So that is the case. So in 1960s, it was TLC technique. But in 2000, instrumental TLC came in picture. Then software control TLC came in picture. Then in 2016, a standardized methodology in many pharmacopoeias they have adopted. So how to do HPTLC with standard protocols uh, by controlling all the technical parameters in depth. And in 2018, many pharmacopoeias across the world, like US pharmacopoeia, then Chinese pharmacopoeia, Japanese pharmacopoeia, European pharmacopoeia accepted HPTLC. Then in 2022, Camag has launched robotic HPTLC, means without any manual intervention. Right now, how we are doing HPTLC, just taking plate from one module to other module manually through our hands. But it is now completely robotic with HPTLC Pro setup. That also we can see in our facility. So this is the evolution, and mostly Camag is there from 1960. So for this evolution, mostly Camag is responsible, we can say. That is bold statement, but Camag invested a lot in R&D by keeping the user needs in front, what exactly they want, and they are designing their modules, instrumental modules in that way. And updating latest features they are updating, it is very competitive with others. So because a few other manufacturers are there in HPTLC business, but they are not upgrading their systems. They are using old softwares, old hardwares. So that is very critical for user. It is not that machines are not user friendly, that much user friendly.
A couple of questions here. You know, if you say this is the evolution, now most of the time the new eras are promoting nanotechnologies or rather miniature technologies, isn't
Yes,
it?
yes.
Because I may not have that much space in my lab.
Yes, yes.
So I want a miniature version of it with all features of the
Yes.
traditional one.
Yes.
Then other thing is, you know, the throughput as far as the samples are
High
concerned.
sample. Yes.
At a stage, I want to, because as a forensic person,
Yes.
so I want in one go many samples to be tested.
Yes, ma'am.
So what is the evolution in that
Yes, yes.
direction?
Yes. So if we see, this is complete Camag HPTLC system setup, right from sample application to chromatographic development, derivatization, detection. So it is a modular system. There are different modules to perform each and every step involved in the analysis. So there are steps involved in the analysis, right from sample application to development, derivatization, detection. For each step, we are using separate instrumental module. So first of all, applicator. Applicator will do application of liquid samples on TLC or HPTLC plate. So we are using spray-on technique and band-wise sample application technique. So we are not spotting the sample on TLC or HPTLC plate manually. It is through automatic sample applicator. And for high sample throughput, as you said, ma'am, here we can keep 66 samples at a time in the vials. The syringe will go automatically in that particular sample, will take appropriate volume
That
of the
needs to be
sample.
programmed initially.
Yes, yes, yes. It is connected to one centralized software.
Okay.
Okay. Yeah. Okay. Yes. Okay, clear? So it is connected to centralized software, that is Vision CAT's latest system control software. So all these modules we can operate through VisionCAD software, and we will get complete analysis report with plate images like this. This is plate image under 366 nanometer. This is chromatogram for quantitative analysis. This is mass spectra after TLC-MS hyphenation. We can hyphenate Hptlc with mass spectrometry, and this is again one image under white light. So not only these four, but many other things like photo, chromatogram, along with TLC-MS spectra, along with absorption spectra. Everything will come in your final report.
Before we proceed, one more.
Yes.
On behalf of them, I am only asking.
Yes.
So we have this, no sample preparation kind of a technology is coming. Like UV visible thing. Earlier we used to do that preparation of the sample, then load. Now we are getting nano drop kind of technologies wherein no preparation of the sample. Once you extract the sample, for example DNA kind of thing, yes, you put a drop over that, and then if you want to, there is an app there.
Yes.
So just select whether you want RNA content, DNA content, protein content, and then whatever you want,
Okay.
just press that.
Okay.
And all other things are taken care by the machine itself.
Okay.
At the end, within seconds, you get the reading displayed on the monitor. So is such technologies available with this system?
No, ma'am. It is still modular system, and we are using it for in a little bit traditional way. With after sample preparation, we are applying it on TLC, Hptlc plate. We are running the plate into mobile phase in development chambers, and then after running the plate, up to this is chromatography, and after this step, these are all spectroscopy and other techniques for detection. Okay, this is up to this is chromatography. This is for detection. We are using spectroscopy.
They come as a separate device or attached?
Separate. These are all different modules. Separate modules. You can see in our lab also. All these modules are here. Different versions of these modules are also there.
Do you have R&D also here? No.
Yes. We are only R&D setup, ma'am. We are not like public testing lab or something. We are selling Camag Hptlc machines, and after sale support we are giving, or we are giving support to our potential customers or existing customers, and we are accepting their challenging samples which they want to do on Hptlc. Means we are developing newer methods for them. So it is complete R&D lab, ma'am. We have all privileges to do complete R&D, different sample preparation methods again. But just we have only one limitation of biological sample handling. So we don't have that facility here. So we are facing that small limitation. But we are fulfilling that needs after visiting on-site labs like RFSLs, SFSLs. We are continuously in touch with them. We are taking reports from them. We are observing the things, how they are doing sample preparation, how the workflow is going on in their lab. So that is the thing. So all these modules are connected to centralized software, VisionCAD software, right from sample application, development, detection. Then for derivatization, we are using Camag derivatizer. Okay. So generally, ma'am said RNA, DNA, all the things after putting in one machine, it is possible nowadays. In nanoscale, technology developed a lot, but in this era also chromatography plays vital role in this era of technological development for selectivity and accurate sensitivity. We are still using these good methods, and for different complex sample matrices, again we need sample preparation and proper separation, and therefore Hptlc still is in with good flow and is in good use of all the users in this sector. So application development, visualizer means for capturing plate images under different illuminations, and scanner means to scan the plate under different wavelengths of light to see the absorption behavior of the molecule, to find out its quantity by plotting calibration plots, and to generate the absorption spectra to match with the library. So library is also there, spectrum library for unknown sample identifications like pesticides, street drugs, or any kind of drug or poison, toxic substances. We have library of more than 740 absorption spectra added in that library. So
You have a
after
provision to extend that also?
Yes, yes, yes. Means after setting up Hptlc setup at any facility, we are installing that library also along with the software. So customer will get all the software as well as hardware and library with the library, Spectrum library.
It will charge different or not?
No, means for forensic library is important, so we are providing with that package only. That is included in the package, Spectrum library. So if you see the basic difference, TLC, HPTLC, what is the main key difference? In TLC, we are taking any dimensions of the plate, we are applying samples and standards in the form of spots rather than bands, and we are drawing any one line at 1 centimeter, 2 centimeter. It is entirely user dependent. यूजर को जैसे लगा उसने उस हिसाब से उसका R&D के हिसाब से अप्लाई किया प्लेट के ऊपर. So there is no any standardized methodology involved, and we are applying manually with capillaries. So capillaries are disturbing the stationary phase, silica gel material. So because of that disturbance, we can see poor separation. Again, spot-wide separation, some molecules will remain on the top of the line, some molecules will be behind of the line. So there is no equal opportunity in front of every molecule to travel in this track. No equal chance. So therefore we can see the merging, or we can see diffusion of separated components, separated spots. Okay. So that all we are avoiding here. We are applying in the form of bands, samples and standards. Here 1, 2, 3, 4, 5 different standards we have applied, and many other samples at the same time. And we can qualitatively analyze it, means whether it is detected in any sample or not at that particular RF value, and if it is detected, how much it is. We can quantify it because of this proper resolution and proper band check. So qualitative and quantitative analysis is possible.
If these bands are proportional to the amount of concentration we applied initially?
Yes, yes, yes. So here we need to load a known amount of standard along with our sample to quantification, for quantification, to quantitate the amount of that particular standard in your sample. So
That means the width of the band is equal to the concentration. That way we can.
yes, yes, yes. So the scanner of the HPTLC system will generate peak response for the band, and that peak area is proportional to amount of the separated analyte.
You said that visualizer or scanner?
Scanner. Here, this is the TLC or HPTLC plate. Okay, this is RF value scale 0.1 to 0.9. Okay, and on this scale we can see different components are separated, and we can find out RF value, that is retardation factor. You know, distance traveled by solute divided by distance traveled by solvent is the retardation factor, either from application position or from bottom of the plate, from anywhere you can take. Okay, so RF value is the key parameter for qualitative analysis. If RF value of this band and this band is same, color is also same, then we can say this band is nothing but detected in the sample at the same RF value. This band is present, this chemical component is present here in this sample. Okay, so after knowing RF value, we want to quantify how much it is. So our scanner will generate peak response and area for that particular separated band, and that area is proportional to amount of this separated band. Okay, so here detection is done in solid state. Okay, this plate, on the plate samples and standards are in solid form. We are keeping it in scanner, and scanner is moving the light from solid components, chemical components, and based on the absorption properties of solid components, it will generate peak area. Okay, suppose I will give you one example of caffeine. Suppose caffeine is having lambda max value, maximum absorption wavelength 276 nanometer. Okay, so if we scan the plate in which we have applied caffeine and green tea sample, or any sample in which we want to detect caffeine. So if we scan the plate under 276 nanometer of light, so caffeine will give us peak, and that peak area is optimized because we are scanning the plate under its lambda max value, and that area is proportional to amount of applied caffeine component on plate. So we will compare the area of sample, unknown sample with known standard. Okay, that is single point calibration curve method, or we can apply different amounts of standard on plate. We can plot the calibration graph, and from calibration graph we will find out amount present in unknown sample. Okay. So this is the key difference: spot-wise application here, band-wise application, proper separation with standardized methodology. We are running it up to only 7 centimeter, 70 mm. We are taking 120 by 10 centimeter plate. That is standardized dimension of the plate, 20 by 10 centimeter. Here, no any standardization. Anyone is cutting in the
come
plate.
as a pre-coated ones, or
Yes,
do we
yes.
need to prepare?
No, we are using pre-coated plates from Merck. Merck is the key manufacturer across the world. You can see Merck is everywhere. Nearly 90% of the plate materials they are manufacturing. Michael Nager, etc. Many other manufacturers are also there. But we are using Merck manufactured TLC, Hptlc plates in our pre-coated plates, and more than 50 different types of plates available. By the it is okay running. Okay, standard running. Okay. So she will be there with us for demonstration purpose, practical demo. So she is preparing samples and keeping the things ready. Yesterday also we have taken one trial. We have simulated one example. We have taken albumin part of the egg, and in that albumin we have spiked some amount of transfluthrin, that is mosquito repellent, locally available, good night mosquito repellent. We have added in that, and we will show you demonstration how it works, how it separates, and in albumin sample how we can detect transfluthrin. That is the
Like for example, food technology also you said you are into.
yes,
Now for example, let us take honey.
yes.
So honey these days, I mean, we cannot trust unless it is from these whatever
Yes.
agency areas.
Yes,
they
yes.
they get only pure. But if suppose some गुड़ का उसमें है मिलावट है,
Yes, yes.
so
Jaggery.
it
Yeah.
will be able to.
Yes, that is good question. Yes, ma'am. We can analyze any sample matrix. We are giving support to FDAs also, not only RFSS, Food and Drugs Administration. Here in Bandra, FDA is there, Maharashtra FDA. So they are coming in our lab always continuously for double confirmation of the results. Their results. They have 3 Hptlc systems. So in case of honey, there is a lot of adulteration of sugars, table sugar or jaggery or something. So it is easy to detect. Mostly table sugar is sucrose. Table sugar is sucrose. So if amount of sucrose is more than 5% in any honey, so that is not acceptable. 5% up to 5% sucrose is acceptable in honey. Means ऐसा नहीं कि 5% उसमें शुगर डालो टेबल शुगर, बट होगी तो चलता है एज पर एफएसएसए है, बट मोर देन 5% इज देयर सुक्रोज, सो वी कैन इजीली डिटेक्ट थ्रू HPTLC. We can separate the sugar bands, and we can find out its amount. If it is not with the ratio, like fructose to glucose ratio is important in honey. Fructose sugar to glucose sugar ratio. That ratio should be within 0.95 to 1.2, in that range. So if that ratio is failing that range, then we can say fructose glucose ratio is disturbed because of addition of any other sugars.
No, why I have asked this question, the department called Camag, agriculture marketing.
Yes.
So they use that marketing for export
Okay.
material. So they are also slowly merging into the other departments,
Yes,
and
yes.
food and
FDA. Yes.
So they are merging into that.
Okay.
So they want to transform a traditional way of doing that, adding chemicals, reagents,
Yes.
looking at the bee.
Biochemical tests.
They are doing that. They want to switch over to technologies like
Yes,
that,
yes. Yes.
So some of them are also gone for training and all.
Yes.
So how that will be useful, like fats, you want to know what is
Yes,
the
yes.
adulteration.
Yes, sir.
Ghee, what is the adulterant
Yes, yes.
present.
Ma'am, we will come on that part. We have all that slides.
Okay.
We did that analysis already, and we have installation in Central Agmark Lab in Nagpur.
Nagpur?
Yes,
Uh-huh.
Central Agmark Lab.
Okay.
So I have visited 4 years back in that lab.
Regionals, they also have regionals.
Okay.
So regionals,
don't know
they are
in
asking
PUNE.
them to upgrade their business.
Okay, okay,
My sister works for Anchrom, that's the reason.
okay, okay. So, ma'am, we will see that all applications,
Okay.
food, herbal, forensic, pharmaceutical, all that
Okay.
applications are we added in last.
Okay.
Okay. So, understood the principle TLC, HPTLC difference. What exactly the HPTLC is? It is modular system. What exactly we are looking for separation of component, and after separation, detection with different techniques like hyphenation. So this is MS interface. We can hyphenate this HPTLC with other. What is hyphenation? You know, literal meaning of hyphenation is adding hyphen between two techniques. LC hyphen MS, HPTLC hyphen MS, LC hyphen MS hyphen MS, LC MS MS, GC MS MS. So hyphen is nothing but addition of 2-3 techniques together for more sensitive, accurate detection and separation. Okay. Generally, hyphenation happen between chromatography and spectroscopy. Okay. Chromatography for separation, LC for separation, MS for detection, MS mass spectrometry for detection. Because LC inbuilt detectors are not capable enough to find out trace amount. So we can hyphenate with mass spectrometry, IR, NMR, LC, NMR, LC, IR. That is also possible. HPTLC, IR, NMR is also possible. Hyphenation means nothing but addition of different detection techniques into our existing skeleton. Okay. So these are all features, and these are all chapters you can note down, or we have provided these chapters in your kit. You can read for further.
You are sharing this PowerPoint also?
Yes, yes. We will share this PowerPoint presentation. You will get all this material. Whatever I am showing in my presentation, all this material with application notes, system details you will get. So this is the standardized methodology. We are taking always 20 by 10 centimeter plate. We are applying 8 mm band on the plate. We are keeping the distance between two bands same and constant. And from one edge of the plate we are applying at a particular distance. From bottom of the plate we are applying at 8 mm. From this corner 20 mm. This is as per USP, United States Pharmacopoeia guidelines for doing HPTLC analysis. Mostly for
Distancing will be done manually or the machine?
no, from machine itself. It is automatic through auto sampler ATS4. It is automatic. And then spot versus band wise application, we can see the difference. And then we are keeping the band length 4 mm, 6 mm, 8 mm, 10 mm, automatic through machine. We can see the difference between separation. There is no difference with band length, but if we decrease the band length, it is more like spot. So spot we will get diffusion, but in more band like shape we will get more proper separation, good resolution. Okay, distance to solvent level that we can maintain 10, 20, 30 mm, 70 mm we can run, but 70 mm is optimized as per guidelines. Then developing distance 7 cm. Chamber saturation, we have to saturate the chamber with the vapors of mobile phase before plate development. Exactly at 33% as per USP for botanical origin material. And relative humidity, we have to maintain 33% relative humidity, chamber saturation time 20 minutes. Okay, for optimized results. These are all features and benefits for research labs. Then,
Excuse me, sir.
huh?
Can you increase the temperature? It's very cold.
Okay, okay. Abhi, it is on 30 already. So I will switch off for
Yeah,
2 minutes.
exactly.
Yeah. Because after coming in the lab here, we have decreased the temperature because many students are there. वहाँ पे So it is 21 CFR compliant, IQ, OQ, PQ qualified. This is general requirement for from pharma industry. So this is stepwise practice of HPTLC. Sample preparation and literature survey is key behind any analysis. Okay, if we prepare it properly, whatever we are taking in our final aliquot or separation If that contains more amount of your analyte of interest, then only the machine will show proper things. Any machine will not do any magic. If the analyte is present in your sample aliquot, then only it will show. If it is not there, your sample extraction procedure is wrong. If some decomposition happened or deterioration of structure happen of analyte, then machine will not show you anything. Okay. After taking final aliquot for Hptlc analysis, just select suitable stationary phase. Okay, means plate selection. Generally 90% of the time we are using TLC, Hptlc plates for separation. But sometimes we have to use different plates like RP plates, reverse phase plate. Hptlc based on adsorption principle and normal phase generally. But we can do reverse phase Hptlc also. RP plates are also available. For some samples like oil and all, Sudan dyes and all, RP plates are very important to use. Reverse phase. You know the difference between normal phase chromatography and reverse phase, correct? नॉर्मल फेज में क्या होता है, स्टेशनरी फेज इज मोर पोलर देन मोबाइल फेज एंड रिवर्स फेज में उल्टा है, स्टेशनरी फेज इज मोर नॉन पोलर देन मोबाइल फेज. ओके, दैट इज द डिफरेंस. Then after selecting suitable plate stationary phase, we have to apply the sample on plate application by using Hptlc applicators. Sample application में भी उसका concentration कितना होना चाहिए, volume, that we need to decide based on our expertise and based on the protocol. If method is there, already existing method, you can follow that. After sample application, chromatographic development in suitable developing chamber like manual twin trough chamber or humidity control chamber or gradient type of Hptlc you can do. Then image documentation. We can capture the plate images under different illumination, UV light, fluorescent light or white light, before derivatization, after derivatization, any time in between the analysis we can capture the plate image. And then after imaging, scanning densitometry to scan the plate under different wavelengths from 190 nanometer to 900 nanometer. That is the range of Camag Hptlc scanners, 190 nanometer to 900 nanometer. Okay, from that region any wavelength we can select for scanning of the plate. And after scanning, if nothing is visible like sugars are not having any chromophoric group, they are carbohydrates generally. So chromophore is not there. How to detect sugars? They are not absorbing any wavelength of light in normal condition. So we have to derivatize the plate. We have to make derivative of sugars on plate derivative. तो जिस प्लेट के ऊपर शुगर को सेपरेट किया है वो प्लेट को आप सुटेबल डेरिवेटाइजिंग रिएजेंट में डिप करो या फिर सुटेबल डेरिवेटाइजिंग रिएजेंट उसके ऊपर स्प्रे करो. तो जनरली आपने एक एग्जांपल देखा होगा अमाइनो एसिड्स का. अमाइनो एसिड्स आर आल्सो नॉट विजिबल टू नेकेड आईज इन नॉर्मल कंडीशन. सो वी हैव टू स्प्रे द प्लेट विथ नीन हाइड्रेन रिएजेंट. सो अमाइनो एसिड्स आर रिएक्टिंग विथ नीन हाइड्रेन, दे आर फॉर्मिंग डेरिवेटिव. नाउ दैट डेरिवेटिव इज डिटेक्टेबल. So for detection of non-chromophoric compounds, we have to derivatize the plate. For that we are using derivatization technique. Okay. So after derivatization, again we can do imaging and scanning of the plate. For sugar analysis, after development nothing is visible. So go for derivatization, then go for scanning and quantification. So this is stepwise practice of Hptlc. Here applicator is required, here development chamber is required, here photo documentation, visualizer is required, here scanner is required, and here derivatizer is required. So all these modules are connected together in the software. In software we can make program, we can give command, and we can transfer the plate from one module to other after completion of each step. Okay. Sample preparation is mostly very easy. For botanical origin material, we can weigh nearly 100 mg and we can add 1 ml of diluent like methanol. We will sonicate it for 15-20 minutes, centrifuge it, and we will apply supernatant on plate. Okay, this is rapid and fast. But most of the time in forensic sciences, generally in narcotics, for ganja leaves, cannabis sativa leaves and all, this technique will be helpful for that raw material powder. But for post-mortem samples, visceral samples, you have to follow your own in-house protocol for sample preparation and final aliquot, this vial. Final aliquot, this solution should be clear, liquid, transparent, without any turbidity, haziness, suspended particles, because it will choke the syringe during application. So after collecting this aliquot, we can apply it on TLC or Hptlc plate. Suitable volume, like in microliters. We have syringes 10 microliters, 25, 100 microliters. So we are applying in microliters, not in milliliters. Always.
After each application, if you want to use the same machine for some other exhibit or some other material,
Yes.
then how that cleaning of that?
Yes, that is very good question. Means very good question, because in Hptlc all these modules you can use simultaneously. Matlab, if we are using applicator, suppose I am doing application of samples on plate. So one of my colleague is doing detection by using visualizer, or scanning by using scanner. So simultaneously we can use different modules, and each plate is new stationary phase. उसके ऊपर अलग अलग सैंपल हो सकते हैं. मेरी प्लेट के ऊपर फूड सेक्टर के सैंपल्स है, मेरा कलीग कर रहा है फॉरेंसिक सेक्टर के सैंपल्स. तो मैंने HPTLC के एप्लीकेटर के ऊपर इफ आई केप food samples, then after application I will go for development. Meanwhile my colleague will come, my colleague can apply forensic samples on plate. So syringe cleaning is fast and rapid with automatic technology. So applicator will automatically rinse the syringe after application of each and every sample, and from plate to plate also in between we can rinse the syringe. This is automatic, no any contamination will carry forward from one plate to other plate or one sample to other sample. That is not possible at all. So after application I will go for development, or if I want to see how bands applied or something, I will go for visualization. Suppose initially I want to check whether it is having chromophore, it is visible in UV light or fluorescent light. I will take image after application also. So simultaneously we can utilize all these modules. कोई हार्ड एंड फास्ट रूल नहीं है कि यही इसी सीक्वेंस को फॉलो करना है. सो फॉर R&D इट इज वेरी गुड, एंड फॉर complex samples it is very good. Suppose something happen after application, we can find out it what exactly happened, bands are applied properly or not. If not applied properly, discard the plate, again prepare sample with other additional steps, and again apply it on plate. So in between you can stop anywhere and you can start again complete running. That is possible.
For cleaning purpose, we use methanol.
That is good question. For cleaning of the syringe, it is depend on solvent. Suppose if you prepared your samples in acetone, so use acetone for syringe rinsing. If you prepared your samples in methanol, use methanol for syringe rinsing. If it is in chloroform, use chloroform generally. But methanol is universal solvent. In our applicators we are keeping methanol. But suppose some solvents are forming any precipitation or something with methanol, then it is difficult. So in that case you have to select that particular solvent only. So these two modules we are using for sample application. This is semi-automatic Linomat 5 with spray-on technique, and this is completely automatic. Here syringe rinsing and filling is manual. Otherwise it is also connected to software. We can program the application volume, band length, etc. in the software. We can give command, but between each new sample and standard we have to rinse the syringe manually and fill the syringe manually with that particular sample. So that part is only manual, otherwise it is automatic like this one. And this is completely automatic. Here your samples you can keep in vials, and in programmed way it will apply the samples on the plate in the bandwise form. All these 4 different kinds of separation applications we can perform. In traditional way, at the bottom in the form of bands we can apply. In the middle of the plate we can apply the band. One long thin band we can apply for preparative isolation of compounds, micro preparative work. And superimpose we can do on plate spiking studies also. एक सैंपल के ऊपर दूसरा सैंपल स्पाइक कर सकते हैं या उसमें स्टैंडर्ड स्पाइक कर सकते हैं. to see the recovery, etc., or to check the proper separation, we are using spiking option also. For development, we have manual chambers, two interrupt chambers, having 3 dimensions, 10 by 10, 20 by 10 and 20 by 20. So we can go up to 20 by 20 centimeter plates, but generally we are using 20 by 10 centimeter plates as per USP. So 3 different dimensions of the chamber, and this is automatic development chamber with humidity control option. We can maintain 33% humidity exactly during chromatographic development. Here this is entirely automatic. Just keep the plate, hang the plate here inside, pour the mobile phases and give command from the top. So it will saturate the chamber automatically. It will maintain the 33% humidity. Plate will go automatically into the mobile phase, come out automatically. And here there is a sensor. That sensor will see the wet portion of the plate, and after reaching the solvent point, it will take out the plate. So no manual observation is required here. Completely automatic development chamber. AMD2, gradient type of Hptlc. You know isocratic and gradient systems. Isocratic means by using single composition of the mobile phase, and gradient means different compositions of the mobile phase during development. Okay, जैसे कि HPLC में होता है कि up to 5 minutes run with methanol, then 5 to 10 minutes methanol plus water, then 10 to 15 minutes methanol water buffer. So mixing of different components, so compositional change of mobile phase, that is possible in Hptlc also. Means up to 10 mm we will run with chloroform, then with methanol, then chloroform plus methanol, then toluene plus acetone. By up to next distance we can develop the plate with different solvents or mixture of solvents. By this way, from lower polarity to higher polarity, so polar to non-polar components we can separate properly by using this technique. This is more useful for R&D. At a time 5 mobile phases or 5 solvents we can keep in the AMD2. Now this is visualizer. After sample application and separation of the components of mixture, separation कैसे होगा? By capillary action से mobile phase move होगा up to marked position, and it will separate the component as per the affinity of component towards stationary phase or mobile phase. Okay. Okay. Shall we take break of 5-10 minutes? You need break or it is okay? We will continue. Fine. We take break for 5 minutes. Then we will start.
क्या बोलते हैं फेवरेट चाहिए
चाहिए
यूज किया है हैदराबाद CFSL. ओके, वहाँ भी है. आई हैव विजिटेड.
या वहाँ पे है, बट उतना वर्किंग कंडीशन में नहीं है.
हाँ,
बट
हाँ.
पुराना वाला मॉडल है.
यस. बट मैम वो जो एक्चुअल वहाँ सैंपल आते हैं ना, बट इफ यू सी एकेडमिक पर्पज बेस लैब में होगा तो कंप्लीट यूज रहता है कंटिन्यूस. जैसे NFSU गांधीनगर में है Hptlc. अभी आई थिंक 2-3 years बैक है. अभी दे आर फॉरेंसिक में जो भी TLC होता है, ऑल दैट वी कैन कन्वर्ट ऑन Hptlc.
You are talking about the degradation, decomposition.
Yes.
That will stuck into the that series.
Yes.
So most of the forensic lab, these items are most of the time they are decomposed only. Probably that is the reason why you are not able to use that so effectively on those samples.
Okay, that is good question, ma'am. Last week I have visited Patna FSL, Patna State Forensic Lab. They are also doing post-mortem samples. They are generally preparing it in acetone and in methanol post-mortem sample. But they are not facing any issue with series. Means the solution is clear after adding acetone. Means generally visceral sample hexane में रहते हैं. After that hexane they are evaporating hexane, and whatever remaining in that petri dish they are adding acetone.
They are recrystallizing it with acid.
Yes, yes. And in that after that that solution is clear most of the time. So they are not facing issue from that.
So we'll start it.
Shall we switch on the AC now? Means,
थोड़ा
ventilation.
इतना भी cooling नहीं.
हाँ हाँ ठीक है. We will keep on 30, 28. Remote. Ritvik, water bottles over. ओके 30 है. थोड़ा देखते हैं. Okay, shall we start then again? So up till now we have seen what exactly the difference between TLC, Hptlc, the basic principle and different modules in Hptlc system, and in that modules application, development, detection module. Now we will start with detection modules. We have seen application and development, so that is the part of chromatography. Apply करो, mobile phase में run करो, separate करो components को. But after separation, how component looks, how they are absorbing light, what is the properties of that component, what are different properties, that we are finding out with detectors. In that first is visualizer, Camag visualizer, TLC visualizer 3 we are using. Here there are 3 lamps, deuterium, tungsten and mercury, to capture plate images under different illuminations. Deuterium lamp is for generation of UV light 254 nanometer. Tungsten lamp is for 540 nanometer white light generation, and mercury lamp is for 366 nanometer fluorescent light generation. Okay, so we can keep the plate inside this visualizer. This is highly sensitive industrial grade camera fitted inside, connected to the software, and software after giving command it will capture the plate image, it will illumine the particular lamp automatically. Image capturing is automatic, and image will come in your software report, analysis report, under UV light, fluorescent light and white light. So you can see this is plate image under UV light, under white light and fluorescent light. So why this plate is greenish in color? Because in silica gel material, while coating, they are adding one indicator which will give you fluorescent greenish color under 254 nanometer light. Okay.
So under different wavelengths, what is the purpose, that better visualization or?
Yes ma'am, because we have to observe the plate under 3 different illuminations, because some molecules are visible in white light, some molecules are visible in UV light, some molecules are showing fluorescent properties, like in plant analysis flavonoids are fluorescent in nature. So flavonoids we have to analyze in fluorescent wavelength. Then some curcuminoids etc. or colorful bands, dyes, inks वगैरह we have to capture under white light. They are visible in white light. Some molecules are not visible in any other wavelength, only in UV light, like caffeine. Caffeine को आपने देखा, it is colorless in white light. It is not fluorescent also, but it is absorbing only UV light. Caffeine is only UV sensitive. So we have to take image under UV light also. So इससे क्या होगा, you will get comprehensive idea कि ये component exactly कौन सा wavelength absorb कर रहा है. And detection के लिए, this is detector, so we can detect कि how many bands are there, how many components are there. If we capture only in single wavelength or something, then we will understand only whether they are absorbing white light or not, or UV light or not. But if we capture under 3, you'll get holistic idea कि ये sample में इतनी components है, some are UV active, some are fluorescent, some are white light active. Then after that, other advantage of Hptlc, it is non-destructive technique. You can see आफ्टर सेपरेशन ऑफ दिस ऑल कंपोनेंट्स ये प्लेट के ऊपर रहेंगे सॉलिड स्टेट में, पकड़ के रहेंगे प्लेट को. ओके फिर वही मॉलिक्यूल्स को यूज करके वी कैन डू डेरिवेटाइजेशन. उसको डेरिवेटाइजिंग रिएजेंट में डीप करेंगे, स्प्रे करेंगे, और वी कैन इल्यूट द पर्टिकुलर जोन and we can find out its molecular mass with hyphenation, Hptlc MS hyphenation. So we can elute this band through MS interface. We can find out its molecular mass in single quadrupole or triple quadrupole MS. We can do structural elucidation, or we can hyphenate, we can elute the eluent, this band, in separate vials, and from that vials we can go for NMR, IR technique also. So we can hyphenate Hptlc with other techniques. So first step in detection is visualization, visual light images, white light image, UV light image and fluorescent light image. Then scanning densitometer to scan the plate. Just keep the plate inside the scanner. Scanner will generate 190 nanometer to 900 nanometer wavelength light, and 3 lamps. Again there are 3 lamps, deuterium, tungsten, mercury. But now here we are using monochromator to chop each single wavelength. अभी उसमें 3 ही वेवलेंथ है, 254, 366 और 540 व्हाइट लाइट. बट इसमें ऑल वेवलेंथ है 190, 191, 192, 193 अप टू 900. वी कैन सिलेक्ट एनी सिंगल वेवलेंथ फॉर स्कैनिंग द प्लेट. ओके, जैसे कि मोस्ट ऑफ द टाइम इन फॉरेंसिक ड्रग्स, पॉइजन्स और टॉक्सिक कंपोनेंट्स, पेस्टिसाइड्स वगैरह, दे आर नॉट एब्जॉर्बिंग 254 लाइट. सो आप क्या बोलेंगे वो यूवी सेंसिटिव नहीं है, बट नहीं, ऐसा नहीं. इन दैट केस दे विल एब्जॉर्ब शॉर्टर वेवलेंथ, हाई एनर्जेटिक 200 नैनोमीटर लाइट. सो वी कैन जनरेट दैट 200 नैनोमीटर बाय यूजिंग स्कैनर. सो वी कैन यूज मल्टी वेवलेंथ ऑप्शन हियर इन स्कैनर टू स्कैन द प्लेट. मीन्स मल्टीपल वेवलेंथ में उसको देखो प्लेट को कि कोई एक वेवलेंथ एब्जॉर्ब कर रहा है क्या. इफ समथिंग इज अननोन, मोस्टली हाँ अननोन एनालिसिस आपका होता है फॉर विसेरल सैंपल और टॉक्सिकोलॉजी, नार्कोटिक्स. तो अननोन के लिए मल्टी वेवलेंथ ऑप्शन इज देयर कि स्कैन द प्लेट अंडर डिफरेंट वेवलेंथ्स ऑफ लाइट, सो दैट ईच एंड एवरी कंपोनेंट वेदर इट इज यूवी एक्टिव और विजिबल और फ्लोरोसेंट वी कैन डिटेक्ट. एंड आफ्टर डिटेक्शन वी कैन गो फॉर इट्स फर्दर इन्वेस्टिगेशन. एग्जैक्टली वो क्या है, प्रॉपर चीजें. ओके, this is the principle of scanner. 3 lamps, deuterium, tungsten, mercury. From that polychromatic light will generate, and monochromator will generate monochromatic light out of polychromatic. What is monochromatic? Means nothing but in simple way we can consider it as single wavelength light. Okay, तो white light lamp on किया तो वो generate करेगा 400 nanometer to 900 पूरा सभी वेवलेंथ. बट आउट ऑफ दैट दिस मोनोक्रोमेटर विल सिलेक्ट ओनली 1 वेवलेंथ जो हमने सेट किया है प्रोग्राम में, या 2 वेवलेंथ, 3 वेवलेंथ अगर मल्टी वेवलेंथ ऑप्शन है. दैट मोनोक्रोमेटिक लाइट विल कम ऑन टू द मिरर, विल फॉल ऑन टू द प्लेट. ओके, एंड इट विल मूव फ्रॉम स्टार्ट टू एंड, एंड some amount of light will reflect from the plate. So it is based on diffuse reflectance. So if reflection is more, then absorption is less. Reflected light is more, then absorption from band is less. So area of the band will be less. If reflection is less, then absorption is more. In that case, area is more. So depend on amount of compound, it will absorb the light or reflect the light. So if reflection is more, amount is less. If reflection is less, amount is more. Okay. So it is proportional, directly proportional. Okay. So we are measuring diffuse reflection from the light, diffusely reflected light, and we are converting it into peak format. And we are plotting the graph of area versus output में area versus RF value. एरिया वर्सेस आरएफ वैल्यू. सपोज एक प्लेट के ऊपर 3 बैंड रहेंगे 0.1, 0.2, 0.3 आरएफ पे, तो इट विल जनरेट 3 पिक्स. इफ देयर आर 10 बैंड्स ऑन द प्लेट, इट विल जनरेट 10 पिक्स. ओके, डिपेंड ऑन देयर आरएफ वैल्यू एंड अमाउंट ऑन प्लेट अमाउंट. So this is whole output we are getting. We can scan the plate, we will get area for quantification, 3D chromatograms, then peak response, then absorption spectra we will generate from 190 nanometer to 400. Absorption spectra is very unique property of any compound. For identification of unknown, it is very important feature property. पेस्टिसाइड्स है, कोई भी ड्रग है लाइक अल्प्राजोलम है, डायजेपैम वगैरह है, सुसाइडल केस है, उसमें विसेरल सैंपल्स में वो डिटेक्ट हुआ, तो इफ इट इज प्रेजेंट और डिटेक्टेड इन योर सैंपल, देन you can match the spectra of that particular poison or cause of death analyte. You can take the spectra of that, you can match with the library. We have library of the spectras in our software, so you can match with the library, and from unknown also you can find out ki it is matching with exactly which drug, alprazolam, diazepam, cause of death you can find out. Okay.
We can measure the area manually or automatically?
No, it is automatic. The software statistics will show you the area, calculated area of each peak. So we'll show you in a practical demo or here also. So this peak area, you can see peak number 1, 2, 3, 4, 5, 6 many peaks, and it has already automatically calculated the peak areas. This violet color portion is nothing but statistics software has applied to the chromatogram and calculated the area of each peak. And by using multi-level calibration curve method, we can quantify the amount of specific analyte from the samples with standard. But here for quantification standards are required generally. And multi-wavelength scanning, जैसे कि मैं बोला, suppose if molecule is not absorbing 254, 366, 548, then हम क्या बोलेंगे उसमें नहीं है? No, that is wrong effort. क्या करना है? Take that plate, keep into the scanner and use multi-wavelength option. Select multiple wavelengths 200, 220, 240 with intervals. 20 नैनोमीटर्स के इंटरवल्स 200, 220, 240 सभी वेवलेंथ में स्कैन करो, कोई ना कोई वेवलेंथ पे आपका जो एनालाइट है अननोन वो एब्जॉर्ब करेगा लाइट. इफ इट इज एब्जॉर्बिंग द लाइट एंड यू विल फाइंड आउट इट, you will detect it. If still after multi-wavelength scanning also it is not visible, then you can go for derivatization. अगर कोई लाइट एब्जॉर्ब ही नहीं कर रहा है तो डेरिवेटाइज कर दो फिर. But from HPTLC scanner is the heart of HPTLC system, and it is very good for detection. It is acting as detector in HPTLC, and by using scanner you can generate spectra match with library. You can do quantitative analysis, quantification, and these two are very important, qualitative and quantitative. Spectral match is qualitative analysis, है कि नहीं है. Okay, जैसे डायजेपैम मिल गया तो उसका स्पेक्ट्रल लाइब्रेरी से मैच हो जाएगा, तो यू कैन रिपोर्ट कि डायजेपैम डिटेक्टेड इन द विसेरल सैंपल, एंड यू कैन शो दिस मैच ऑफ स्पेक्ट्रास. यू कैन शो द RF वैल्यूज, कलर अंडर डिफरेंट इल्यूमिनेशंस, एंड यू कैन डबल कंफर्म कि वही था, डायजेपैम ही था, या कोई दूसरा नेरियम ओलियंडर का भी जो पॉइजन रहता है उससे हुआ, या एट्रोपाइन है, या कोई भी अल्कलॉइड है, कोई भी नार्कोटिक्स है उसमें भी CBN, CBD, THC. So you will get all these output through scanner as well as visualizer. These two are main detectors. So you can see sulfomethoxazole, trimethoprim, dimetronidazole having different absorption spectra. सबका absorption spectra अलग है. Because what is absorption spectra? It is property of that molecule to absorb different wavelengths of light. और हर एक मॉलिक्यूल अगर अलग है स्ट्रक्चरली तो उसका प्रॉपर्टीज भी एब्जॉर्प्शन का अलग होगा, एंड यू विल गेट डिफरेंट एब्जॉर्प्शन स्पेक्ट्रा एंड लैम्डा मैक्स वैल्यूज. ओके, सो बाय कंपेयरिंग दिस स्पेक्ट्रा इट प्लेज वाइटल रोल इन फॉरेंसिक साइंसेस, स्पेक्ट्रल एनालिसिस एंड डिटेक्शन फ्रॉम अननोन सैंपल्स. ओके, सी हियर THC, tetrahydrocannabinol, is not visible here under 254 nanometer light, but after scanning the plate under 210 nanometer, it is you can see the peak response here. This bigger peak is because of this band 0.3 RF value, but 0.3 के आगे 0.4 पे जो बैंड यहाँ है, but it is not visible under 254. But after scanning the plate, इसको स्कैन किया 210 नैनोमीटर में, 210 नैनोमीटर में स्कैन करने के बाद you can see the peak response. So if we visualize the plate only under 254 and say कि only one component is UV active detected, no. Take the plate, do multi-wavelength scanning, कोई ना कोई wavelength में वो वहाँ जो अगर बैंड होगा तो it will absorb and show you the peak response.
लास्ट वाला सैंपल क्या था? THC है क्या?
ये अलग अलग सैंपल थे, ये
ये
स्टैंडर्ड,
पूरे डेल्टा 9 THC 3 है ना?
हाँ,
Last
these are all standards and ये confiscated sample
Sample.
रहेगा उनका, उसमें they have detected THC along with other components. Yeah. Okay. So therefore visualization is very important. Along with that, scanner is also very important. Scanner plays also vital role. Okay. Then comparison viewer option is there in VisionCat software. We can compare different samples together in a stack. You know the concept of Hptlc fingerprint. Hptlc fingerprint. I will explain you what exactly the fingerprint is. Suppose we have applied our sample here. It is mixture of many components, and if we run the plate in the mobile phase, the components will move up to solvent track. Huh? So from start position to end position, this is like one track, and we can say it is fingerprint, Hptlc fingerprint of this applied sample in this mobile phase under these chromatographic conditions. Okay, so this is Hptlc fingerprint of this sample under UV light. This is fingerprint of same sample under fluorescent light. This is after derivatization under white light. This is after derivatization under fluorescent light. Okay, so एक ही sample के 1, 2, 3, 4 अलग-अलग fingerprint हमें मिल गए पूरे. Lot of information we are gathering in Hptlc. We are getting for unknown identification. It is very useful. So one fingerprint of one sample, other fingerprint of other sample, all together we can compare in comparison viewer option. Or we have spectra also. We will take spectra of this band, this band, this band, and we will match. We try to match whether they are matching or not. Correlation is good or not. If it is correlation is good for unknown identification, it is very important. Okay. So comparison viewer option is available with our software and visualizer. And for derivatization, we are using automatic spray derivatizer. So it will generate a very fine mist or aerosols of the liquid derivatizing reagent. Only 2 to 3 ml reagent is required to derivatize the plate, and it will generate fine mist. That mist will settle down onto the plate, homogeneously derivatize the plate without intervention of user. And after that, after spraying the plate with derivatizing reagent, it will suck back all the vapors generated in this hood of derivatizing reagent. So it is green technique also, eco-friendly technique also. Only 2 to 3 ml reagent is required. And after that, after spraying the reagent, sometimes we need to heat the plate. जैसे अमाइनो एसिड के केस में नीम हाइड्रोजन स्प्रे करने के बाद हम हीट करते हैं 110 पे या 100 डिग्री पे 5 minutes 10 minutes. For that we are using plate heater, Camag plate heater. Okay, this is specially designed by keeping this TLC needs in front and specially designed by Camag technology. Here 20 to 200 degrees Celsius, 25 to we can maintain at the same time. Okay.
Do you refill with the chromato agent for derivatization?
Yes.
How frequently it has to be done? As in when it's manual or it is also automatic?
It is automatic, ma'am. Here we need to add reagent in this nozzle and just press this button. So it will start spraying the reagent onto the plate. The reagent will fall onto the plate in the form of aerosols. Very small and fine mix.
We need to calculate how many need to be derivatized. Accordingly, that much solution need to be added.
No, only 2 to 3 ml always.
Okay.
The volume of reagent is fixed. 2 to 3 ml for 20 by 10 or 20 by 20 plates, bigger plates also. Any plate less than 20 by 20 we can keep in derivatizer.
Sir, if you don't have a plate heater, so
Yeah.
can we put in a modern oven?
Yes. But the advantage of plate heater is it is uniformly heating the plate from all the sides. In oven, it is heating from all sides, means kahi se bhi, niche se bhi, from everywhere it is heating the bands and reactant A plus B, because A on plate.
But then this kind of heaters with normally with that thermostat and all, it comes no. What is
Yes,
the specialty of it?
Yes, the specialty is this material is very much resistant towards acid or bases falling on its surface. So mostly we are using derivatizing reagents with added sulfuric acid, acetic acid in that. So in normal heaters that provision is not there. They are not rugged. So उसका surface damage हो सकता है and उसका जो sensor है it will not sense the exact temperature जो चाहिए. But in that severe conditions also highly acidic or basic condition.
What is the coating on that person?
It is material of glass coated patented technology. I will show you. Nextim it is heating surface resistant to all common heat. Nextim is one patented technology.
Something
Yes,
similar
yes.
to glass.
Yes, yes. I'll give you all specifications of this material. So in phytochemical analysis, these different derivatizing reagents. Just ma'am said they are doing currently in test tubes, biochemical test for alkaloid detection, for phenols detection. So all that similar kind of biochemical test we can convert on HPTLC. जैसे कि after separation we want to detect phenol, so dip the plate into alcoholic FeCl3 reagent. So phenolic components will show you blue color bands, bluish color bands. And then Dragon-Duff reagent, the alkaloids will show you orange color band. This is TLC-MS interface for hyphenation. Mostly in visceral sample or narcotic samples, unknown compounds are there. We want to find out the separated band, uska spectra to liya, but after taking spectra, we want to find out molecular mass of that compound. So we can hyphenate HPTLC with MS by using this TLC-MS interface. After separation, we can keep the plate on interface. Interface will focus on a particular band of interest, and by using suitable solvent flow, it will suck the band and it will inject into suitable detector, mostly MS we are using. It will show you the molecular mass of the separated component. So the schematic diagram of TLC-MS interface. This is the plate. Here separation happened. We have separated the component. This is the TLC-MS interface head. The head of this interface, one end, inlet end, is connected to Hptlc pump, and outlet end is connected to mass spectrometer. Outlet end. So from Hptlc pump, suitable solvent with the flow rate of 0.3 ml per minute will fall onto the plate, will dissolve the band of interest, and the nitrogen gas pressure action will suck the band of interest along with this solvent, and it will inject it into MS. From outlet tubing it will come out and it will go into MS. And while going into MS, what are silica particles coming out from the plate? It will get filtered out here in the plate. So only this band with your solvent, it will go into MS. Suppose there are 1, 2, 3 bands on the plate. We want to find out the molecular mass of this middle band. We can focus on that. We can elute this band into mass spectrometer. So that is the function of TLC-MS interface. We need any simple pneumatic pump or Hptlc pump to generate a flow rate of 0.3 ml per minute of solvent. That flow will fall onto the plate, dissolve the band of interest, and it will suck automatically through nitrogen gas pressure action. That flow will go into MS, and without connecting it into MS, we can collect the eluent into separate vials. That is also.
Externally, we need to supply this nitrogen pump, or internally it is inbuilt?
It is inbuilt. We have to connect one tubing, peak tubing, to pump and this interface, this peak tubing, and one outlet peak tubing to MS with ferrules. That is, within 2 minutes we can connect this interface with Hptlc pump and at one side MS. Or without connecting this into MS, we can collect the eluent in separate vials. Vials में collect करके फिर उसको GC में भी डाल सकते हैं, या फिर if you want to go for further separation in LC, that is also possible. This is one example. We have separated different flavonoids from chickpea sample, and from that we have eluted different bands, green color fluorescent compounds. Out of many compounds, one compound we found at 447 response molecular mass. That is, I think, Camphorol. Camphorol was the flavonoid we have detected in chickpea sample. through TLCMS interface. HPTLC पहले अच्छे से करना है. See, always chromatography separation should be proper. Then only you can focus on particular band. Band अगर merge हो रहे हैं तो TLCMS will not that be effective. Okay, band if they are separated properly with method development, then we can elute it and we can find out its mass. Then here you can see tadalafil in Ayurvedic samples. They are adding sildenafil, tadalafil, etc. into Ayurvedic formulations. So tadalafil is not visible under 254 nanometer light. So we have scanned the plate under 288 nanometer. So we got the peak response and we have eluted the bands at that particular RF value of the peak into MS. And standard tadalafil 390 molecular mass and in sample tadalafil 390 molecular mass in positive mode and in negative modes. In standard and sample. So this is standard, this is sample. Not visible under 254. Visible under 288 nanometer. इसके ऊपर जो पीक मिले जो RF पे उसी RF के हिसाब से यहाँ मार्किंग किया and we have eluted these two bands, standard and sample. So that is the speciality of TLCMS. We can hyphenate HPTLC with mass spectrometer.
So mass में analyzer कौन सा है?
Mass में there are many means it is it is compatible with any make of mass spectrometer like Shimadzu, Sci-X, Thermo Fisher, Waters. It is compatible with any make single quadrupole or triple quadrupole also. Any make.
Ionization.
Any ionization mode, but it is depend on the CPCI or ESI. Any ionization mode we can use. It is depend on properties of the molecule. This poster we have presented at ASMS conference in USA in 2015. We have separated quinones from Tectona grandis leaf extract, quinones at different RF values, and we have focused on particular quinone and eluted that into triple quad MS and structural elucidation we did. Then this is HPTLC Pro, completely automatic online system, right from sample plate storage, sample application development, derivatization, detection, MS interface, everything is inbuilt, fitted together. It is conveyor belt type of assembly. The plate will go from one module to other module automatically. In plate storage module at a time we can keep 5 plates here and 5 plates for ongoing analysis. So total 10 plates. So 5 plates we will keep here, blank plates. Then in applicator we can keep 77 samples, 77 different samples. In development we can keep 3 different mobile faces and 5 plates at the same time we can program. Like will go one by one. After application it will go in development, then derivatization. After completion it will again come back here in completed plate holder. So where the methods are fixed, if you know कि ये method है, इसी से हमें high sample throughput करना है, 75 samples at the same time करना है, so we can use this HPTLC Pro. Mostly in quality control labs, pharmaceutical labs, it is very useful. Where methods are set, ये mobile phase है, ये sample nature है, ये derivatizing reagent है. Now proceed with analyze all this for batch to batch consistency, raw material analysis, finished product batch to batch analysis. We can use this very effectively. Method development involves all these steps and we can validate the HPTLC methods. With ICH Q2 R2 latest guidelines, complete validation we can do. So that is possible only in HPTLC, not in TLC, because lack of reproducibility in TLC. But here we will get reproducible results, plate to plate, lab to lab, day to day, analyst to analyst. So this is books and literature available for HPTLC plant drug analysis by Wagner, and in toxicology also there is one book that is like Bible. In toxicology,
We have Narayan Reddy है, Pillai है.
okay. In forensic toxicology, we have also one book. I'll show you that. For it is useful for forensic toxicology. You can do literature survey. You can visit HPTLC Association method for plant-based methods. You can visit Camag website. Camag is the world leader. You can create your free login on Camag and you can access many application page. In forensic also latest they have published nerve agent के ऊपर chemical warfare में जो nerve agent वगैरह use होती है. Yes, cholinesteres के ऊपर जो active है, they have developed method for that nerve agents. So I will show you that method also. And Anchrom website, here you can make your login and download different methods. I'll show you that cholinesteres in between, just for change. Yes. These are different chemical warfare. Yes, इसमें आपके किट में भी है warfare agent nerve agent का. Yes. So you can see the possibilities with Hptlc to detect this nerve agent from any kind of sample matrix. It is very easy, fast and rapid. You can see blistering agents and irritants, arsenic agents also. And this is active bands, active towards acetylcholinesterase. Inhibition zones, we can say. Very useful. Dr. Tindu, now Chief Scientific Officer at Camag. So everything they have given, spraying solution, sample application volume, all chromatographic conditions they have provided. We just need to follow that, we can find out. So these type of application notes Camag is always publishing for user support. Means for challenging samples, etc. They are accepting and they are developing methods on that. This is very good method. Recently they have published in their CBS 132 forensic field. There are other two methods also we have added in your kit. Very useful in chemical warfare. Now while coming back to again overview of Hptlc, what you understood up till now. And now we will start with application part for 10-15 minutes more. 1 minute. Vaidehi? Okay. Analysis is okay, na? 10-15 minutes के बाद after application part over, 12-15 को हम. So understood any doubt up till now, sir? Students.
Before he moves on to the other aspect.
ओके ठीक है. नो डाउट मीन्स आइदर पूरा समझा है या थोड़ा नहीं समझा है.
Can I, are you analyze any ink sample?
Yes. I have one example of that. I'll show you.
Documents में ज़्यादा काम
Documents में ज़्यादा आता है.
Yes.
Because
जो आपने अभी बताया था अभी, वो बैंड के साइज का लेते हैं 2 mm, 6 mm, 4 mm,
Yes.
वो अलग-अलग क्यों लेते हैं?
No, that is just for demo purpose. We can apply any band length. Band length is fixed. 8 mm हमेशा लेना है as per USP. 8 mm.
एक ही सैंपल का आप अलग-अलग
Just for demo purposes, we have added that slide. Demo purpose we have added. कि we can apply 2 mm band, 4 mm band, 6 mm band, 8 mm band, 10 mm band. But the band length in which we are getting best optimal separation, that we have to select. And as per United States Pharmacopoeia, band length should be 8 mm. 8 mm is optimized band length. So they have selected 8 mm for generalized purpose. But sometimes if you feel ki in 6 mm separation is good and detection is good, more sensitive, we can select 6 mm band length. That is possible.
Hit and trial. You need to keep experimenting.
No. 8 mm is always fixed.
Ah.
For any forensic, food, herbal, any sample, we are using 8 mm fixed length. In applications, mostly first of all we will check the forensic application first. So, identification and quantification of different cannabinoids in cannabis sativa. So, generally THC, THCA, they have separated. This is the sample track number 1. You can see in track number 1 CBN, THC and CBD. So this is CBN, THC and CBD. Detected in literally in each sample nearly. Some samples are from police, some samples are standards of ganja leaves, etc. They have applied, and at a time 27 different tracks they have compared together, and 26 different samples they have compared together their fingerprints on single screen. So that is the speciality of software, that is additional features in Camag Hptlc software. Different fingerprints at the same time we can compare on the screen, same screen. So in each sample these three are detected. So intensity is sometimes higher, sometimes lesser. That is depend on variation of that amount in your sample. Intensity is less or high. That is because of amount and sample nature. Okay. Then screening method for identification of forensic drugs. Different forensic drugs like ketamine, silicosine, codeine, heroin, methadone, means different kinds of street drugs as well as poisonous drugs, or we can say forensic drugs.
So where did you conduct this work?
Huh?
कहाँ करेगा वो?
This is Camag application note.
Like they have-
Yes, they have screened.
They have screened.
They have screened in their
They screened for
facility.
fentanyl also, LSD. Standards they had.
Yes, they had standards.
तो इसका library है अभी?
Yes. Library in the sense we will provide you absorption spectra of all this along with these images also. Means next time if you develop with the same chromatographic condition, you will get same RF values and color. So you can see ki we have detected band at so and so RF value. So it is matching with literature with codeine. So codeine will be there in your sample. So nearly 13 different forensic drugs separated and images under different illumination, UV light, white light, fluorescent light, before and after derivatization.
But most of the markets are now flooded with designer drugs. They are just modifying only a
One
small
function.
quantity of the whole thing. Either hydroxy group, remove that, add methyl group, like that. So that results in more and more potent kind of designer drugs.
Okay.
So how effective will be your mission with that? Designer
Okay.
drug?
For designer drugs, we can say, ma'am, ki derivatizing reagent. We can use different derivatizing reagents selective towards a particular drug. So for two different designs of similar skeleton, the derivatizing, after derivatization, that two different designs will show different color bands. Like one will turns into blue, one other will, because of structural difference, other will turns into yellow. So after derivatization, we can differentiate between designer drugs. That is one possibility. And we can do TLCMS analysis also. We can elute and find out molecular mass, or we can do derivatization and spectra, absorption spectra also we can generate, and by using spectra we can differentiate between designer drugs. This is rapid separation, detection and quantification of explosives. Explosives may be TNT, PETN, NG, tetryl, RDX, different explosives separated after derivatization with KOH and grease, and after derivatization with diphenylamine. So calibration curves of RDS, quantification भी किया है, not only qualitative work. You know, qualitative means RF values, absorption spectra match करना है, color match करना है. After that, quantification also with standards. You can see standard matching with samples. Means ये standard के spectra, it will come in your library now. Yes, spectra. So if any unknown sample, you can compare in the library spectra, and you will show the matching, whether it is matching with tetryl or TNT or RDS. Based on that, you can decide कि unknown compound में क्या है exactly. Detection of steroids and SARMs. Steroids जैसे कि boldenone, trenbolone, nandrolone, etc. you can separate at different RF. This is after derivatization image under white light and fluorescent light. So you can see color of each steroid is different after derivatization, each band. and the absorption spectra is also different, and molecular mass after hyphenation with MS. Sir, ink analysis, you have asked the HPTLC fingerprint of inks. So उसमें each ink is having its own characteristic. जैसे कि same manufacturer है, same ball pen use किया तो उसमें ink भी similar हो सकते हैं same manufacturer की. But अगर two different kinds of pens अगर use किए हैं या फिर कुछ ink में difference है, तो you will get different fingerprints of that. Suppose these three are from one sample. This one is from second sample, this third sample, 4, 5, 6. So हर एक का chemical fingerprint is different. HPTLC fingerprint is different, and the components are having intensity difference also. Intensity इसमें इसका ज़्यादा, इसमें कम है, इसमें वो compound है ही नहीं. At same RF value having same color. So each ink is having its own kind of HPTLC fingerprint. So based on that we can differentiate between two inks.
CV के साथ कंपेयर किया क्या?
हाँ.
CV क्रिस्टल वाले के साथ कंपेयर किया?
हाँ, वो जनरली उसी के साथ जो उसका बेस कलर है एज है उसके साथ कंपेयर कर सकते हैं हम. इफ यू आर स्टैंडर्ड ऑफ इंक का जो जनरल बेस मटेरियल होता है, जैसे क्रिस्टल वायलेट इज कॉमन कलर, उसको भी अननोन सैंपल के साथ लगा के यू कैन कंपेयर. Then this is fatal suicidal poisoning by chloroquine in presence of alcohol. So ये visceral samples थोड़ा सा separation में this type of separation कभी कभी मिलता है. Observe this is old paper, old literature, but after separation you will get these two bands having UV absorption properties. So we can take absorption spectra of this and we can match the spectra with the library and we can find out it is because of chloroquine. It will show you the matching with chloroquine absorption spectra जो already library में डाले हुए हैं. Then this is normal phase and reverse phase HPTLC, NP and RP HPTLC. So on normal phase BFI उससे exactly उल्टा sequence reverse phase में आपको मिलेगा. Normal के exactly उल्टा reverse phase में, दोनों में it is giving proper separation of this bupropion, then flubendamide and imidacloprid etc. compounds. Okay, this is with standards. Similar kind of separation you will get in your actual samples. At same RF value, if you see this band, their spectra are matching, then you can say this is detected in our samples. These are actual cases. Actually, these are all papers published from different RFSL scientific officers. क्लोरपाइरिफॉस, ये ऑर्गेनो क्लोरेट है, ऑर्गेनोफॉस्फेट, ये सभी चीज़ें वी कैन डू बाय यूजिंग HPTLC. ऑर्गेनोफॉस्फेट्स, एंडोसल्फान वगैरह है, ऑर्गेनोसल्फेट्स, ये ऑल वी कैन एनालाइज. सो दिस इज स्पेक्ट्रा ऑफ क्लोरपाइरिफॉस एंड मैचिंग विथ आवर सैंपल में जिसमें क्लोरपाइरिफॉस था उसके साथ मैच हो रहा है. RF वैल्यू इज मैचिंग, कलर इज मैचिंग, सो वी कैन से कि chlorpyrifos is detected in visceral sample. Then ये cardenolides of Nerium oleander by HPTLC in autopsy samples. So blood sample, stomach tissues, twig of Nerium oleander, flower of Nerium oleander and leaf of Nerium. If some bands are detected in blood which are common in stomach tissues and twig and flower of Nerium oleander, then we can say कि it contains Nerium का कुछ portion either from flower, leaves. Cardenolides will be there in our blood sample or visceral samples. Now this all were forensic applications. Some applications from herbal I will show you. In herbal analysis, beauty of monosperma, red flower and yellow flower, we can differentiate between two species, and this is the main difference. HPTLC fingerprint is unique for different species like Piper nigrum, Piper longum, Piper retrofractum, Piper cubica, Piper borbenensis. Same Piper family, Piper species, but different plants. having different Hptlc fingerprints. Some marker bands are common, like this is piperine. Piperine is common in all piper species. Okay, in less or more amount. Piperine is common, but other marker is not detected in some of the samples. But their chemical Hptlc fingerprints are different from each other because they are from similar piper species. Therefore, some chemicals are common in all, but some chemicals are different based on their species to species, geographical condition, cultivation time, etc. So we can compare different samples at the same time together on a single screen. By using Hptlc fingerprint technique, we can differentiate between two samples. पाइपर नाइग्राम एग्जैक्टली कैसे दिखता है और पाइपर लॉन्गम दोनों में क्या डिफरेंस है दैट वी कैन विजुअलाइज. एनी लेमैन आल्सो कैन से कि दिस इज डिफरेंट based on the color intensity of separated bands, their RF values and position.
कितने प्रिसाइज बैंड मिलते हैं हमें?
Sir, from 0 position to start position to 70 mm up to 70 mm depend on polarity, but your analysis should be targeted कि हमें इसमें इंटरेस्ट है, ये मॉलिक्यूल्स में इंटरेस्ट है, so you will select the mobile phase accordingly and you have to focus on your particular bands of interest कि ये 4-5 components है, ये हमें separated चाहिए from other sample, then you will get very good separation. Generally all sample polarities के सभी हम 3 different polarity use करके separate कर सकते हैं. Now this is example of quantification of marker from botanical origin material, lupiol from Jyotish method. Then some food applications, as ma'am said, rhodamine in food products. Rhodamine is highly carcinogenic dye and they are adding in like cotton candy, you know, बुड्ढी के बाल जिसे बोलते हैं, वो कॉमनली पिंक कलर का एक ऐसा कॉटन जैसा हम खाते हैं जनरली, उसमें शुगर सिरप वगैरह डालते हैं बट कलर भी डालते हैं, और कलर अगर परमिटेड है फूड कलर तो इट इज ओके, बट देयर समटाइम्स सम पीपल आर एडिंग rhodamine also. Rhodamine is highly carcinogenic for generation of high intensity color. So वो अगर डाला है in cotton candy like something, और in lipsticks also we have detected rhodamine sometimes locally made or locally available. So in that case it will be severe, means continuous use of that. Then MSG monosodium glutamate, ये फ्लेवरिंग एजेंट है, जैसे हम चिप्स वगैरह खाते हैं उसमें पोटैटो चिप्स से ही ये किया MSG, एक पर्टिकुलर अमाउंट रहता है MSG का, जैसे चाइनीज वगैरह खाते हैं उसमें अजीनोमोटो डालते हैं, दैट इज नथिंग बट MSG. सो उसका क्वांटिटी एक लिमिट तक होना चाहिए, बट उसके बाद अगर होगा तो इट इज नॉट गुड फॉर हेल्थ. यस, सो वी कैन डिटेक्ट द प्रेजेंस ऑफ MSG, वी कैन क्वांटिफाई इट. Then this is example of different sugar detection in liquors like vodka, rum sample. We can detect sucrose, and this is I think fructose and glucose sugars are detected. So liquors में कितना sugar होना चाहिए, that is also decided by FSS. अगर if it exceeds the limit, it is not accepted. So we can detect the sugar level in.
So can that also detect the adulterants? Because most of the liquors are being banned,
Yes.
not for the content of these things, but
Yes.
more adverse. I mean,
Yes,
things
spirit
can create
वगैरह.
harm to the body.
Yes, spirit also they are adding. in
Spirit
liquor.
and others like
Methanol
floral
added in
floral hydrate.
वो they are all liquid adulterants and volatile in nature mostly. तो GCMS is good technique for that.
Not this.
This is very good for dye वगैरह etc. If they are adding any color dye, colorant into or sugars or any jaggery को ये करके ferment करके वगैरह ऐसा कुछ डाला तो we can detect through this
You
technique.
will say this is tolerable, sugars not very harmful, but when it comes to adulterants,
Yes,
especially this chloral hydrate and then this methyl alcohol.
Methyl alcohol. Yes.
These are little
Methanol. Methanol is
they are
means not
common adulterant
Yes,
which
yes.
is being
Yes.
used for
मिथेनॉल के
Somebody
लिए
can
GC
lose life
is best
also.
suited. Yes. Methanol is highly evaporative, na? Because we are preparing our samples in methanol itself. We are applying on plate, and after application, methanol evaporating out from the plate. So detection is critical on PLC. So, ma'am, honey में I told you कि once FDA had submitted us the sample to detect the here. Sometimes we are doing the cases also. So in that case, suppose glucose, fructose, sucrose, maltose standards we have applied along with honey sample. So maltose is detected, sucrose is not detected, fructose and glucose is detected. Fructose and glucose are there in honey samples. वो उसका part ही है. But that should be in the ratio 0.95 to 1.5 के ratio में होना चाहिए. हाँ, fructose to glucose ratio. But in this sample we found that that ratio is 0.78. It is below the range. And added maltose sugar, maltose
So
dextrins.
these are on complaint, or you just at random picked up the samples and tried to
No,
analyze?
they have just given samples. उसका आगे जाके क्या हुआ वो
Food
confidential है. But this type of critical method also we can solve. These cases also we can solve with Hptlc. Very in finite way, very effective way, sensitive way. जैसे maltose exactly detect हुआ, sucrose is not detected, but ग्लूकोज फ्रुक्टोज रेशियो क्वांटिफाई करके वी कैन प्रोवाइड उसका रेशियो कितना है ग्लूकोज इज
But most of the time, the quality of the honey, not based on the sugar content or the proportionality of sucrose vis-a-vis the fructose, but it is the species from which the pollen is coming.
Yes,
Most
yes.
of them, that is the deciding
floral
factor.
different monofloral or multifloral honey. So we have very good methods on that also. There are total 7 to 8 methods, Hptlc methods for honey.
Honey.
So I have added only one slide because it is more about forensic, but I will show you that 7 others also during our
Because quality-wise, only
Yeah.
few species yield good quality.
Yes. So we can differentiate, ma'am, monofloral honey and polyfloral honey, and which from which flowers वो भी हम identify कर सकते हैं. Means flower exact standard we can apply with the honey. If some common bands detected, yes. If some common bands from flowers detected in honey, we can identify that. Then some pharma applications like dexamethasone, ciprofloxacin from eye drop sample we have detected. Then checking the assay value of primacetine sulfate in sopramycin skin cream. Then cosmetic applications में eugenol detection from toothpaste sample. So this cream toothpaste are creamy in nature. So any kind of tricky samples like creams, etc., ointments, paste, that also we can process and we can do Hptlc analysis. We have detected eugenol like Patanjali, Dantakanti वगैरह अलग अलग अभी they are claiming कि they are adding eugenol into it or clove. So to show the presence of that, we can use this method. That's all from my side from instrumentation and applications of Hptlc. We will see the live demo in the lab within 5-10 minutes more after the break. We will start the demonstration and I will show you the software hardware part in our laboratory. Okay, thank you. We are not only traders, we are technologists also. This is our laboratory and these are all content details. Thank you. And we have simulated one experiment. Albumin mein we have added that good night mosquito repellent. We will see how in spike sample how we can detect it. Okay.
That's some sample from
Yes.
How much time does it take, would it take for a normal person to learn the instrumentation software?
That is good question. Hptlc is very user friendly and within few days training you can do complete analysis and operational work you can learn within 2-3 days also. Only operational work, in-depth principle and all you will get within few days training. Only you can start handling. Here the critical part is syringe handling, Dinomat 5 or ATS4. That is the only. But if you have automatic sampler, then that is also not that way. So just software में program बनाना है. Software is very easy, user friendly, well animated. You can learn it within a few days. You will learn whole things in the software. So it is fast. It is, and here pressure is not involved, vacuum is not involved, temperature maintenance is not required. So therefore the instruments are very rugged and 15-20 years it may run with normal conditions. Only consumables are like lamps, syringe, etc. consumables, but other machines are rugged and robust.
Normally, how many days do you recommend for a fresher, those who are working, those who are at the higher stage of management?
डिपेंड मैम हर एक का
नहीं एक्सपीरियंस जो होता है ना मिडिल मैनेजमेंट वाला हायर मैनेजमेंट वाला इनका तो सीनियर्स बनते हैं ना.
हाँ 3 to 4 days के ट्रेनिंग में जनरली फॉर सीनियर्स those who have used HPTLC before or some knowledge of TLC HPTLC फ्रेशर्स को भी मैक्सिमम 1-2 times ट्रेनिंग के बाद 3 days के हो जाता है.
Otherwise you stagger the training programs and then periodically do how
we are giving complete training support ma'am. Installation training, on-site trainings we are arranging 6 monthly or once in a year we are arranging online also. Ma'am, we have YouTube channels, I will show you. On YouTube channels we have added the videos, operational videos of HPTLC system, so anyone can learn anytime from their homes also.
nothing like seeing, touching, learning rather than YouTube वगैरह
Yes,
that will not give that feel.
Do you have any facility for dissertation for students?
Dissertation.
Last semester they have this dissertation work they are supposed to submit. Can there be well and good if I buy and all that's okay, but in case
I will check with the vice president. Yes.
last time they return by that time they buy that's okay, but then otherwise.
So here we have posted troubleshooting videos as well as operational videos also.
Okay.
Here you can see only 40 minutes video. In 40 minutes you will learn all HPTLC. Tutorial videos, 40 minutes. I request you to please
Welcome.
subscribe our
My name is Akshay Charegavkar. I am the director of Anchrom Enterprises. We are the exclusive folder in which the files of the analysis are to be stored. Click on New button to start analysis
This
using
type of
Camag.
tutorial videos we have prepared. Already we have
What is
posted.
the site you said?
Ma'am, Anchrom. YouTube. Anchrom. Just type ANCHROM on YouTube. You'll get it. And other side, Camag. So here you can create your own login. You can download many methods. So here in section wise they have provided the application notes different. Camag, CAMAG, Camag.com. Here we have given all the new application notes, chemical warfare agents, rapid suppression of explosive, then tetrahydrocannabinol in cannabis. The nicotine in e-cigarettes, nicotine in e-cigarettes, and then synthesis of novel argoline lights. Okay, then we will take break for 5 minutes, then we will start in the lab. Thanks.
थोड़ा ध्यान होता है उसमें नहीं the experiment gets spoiled after some time. Because they can have
वो तो अप्लाई करेंगे सब
अभी देखेंगे क्या इनका क्या
Another check.
Yeah, good afternoon. Good afternoon, everyone.
After lunch, probably we will go there and then
Okay.
meet you.
We met.
चलेगा. That will be best.
Best.
Just we will take just one short lab tour for 5-10 minutes. Then we will proceed for lunch.
Yes, sir. That means we'll do the demo after the lunch.
After
that
चलेगा.
would
Okay.
be
That will be great. Okay. चलेगा.
So how was the presentation? Understood everything?
It was very educative.
Okay. So you'll be able to do the viscera samples now? That's asking for too much, huh? Okay. You have seen that library also, no? Library must have told you.
हाँ हाँ.
We have a preset spectrum library where you have an unknown sample and then it can be easily detected.
Told us.
So we have got about 1,200 or something, which has been a big job done by Camag some years ago before. But now they are just upgrading that to the new software, that is the Vision Cats. Maybe in another 1 month we'll get the whole set of all those 1,200 witches of narcotics, spurious drugs. These are very important, the forensic, because all these cases come to the forensic lab only. Which now you will have to start. I mean, the students have to start in the NFSU also. And then this becomes a big legal problem, you know. You'll have to go and attend the court, proving that this is so and so. Okay, thank you. You all can go. I will wait for lunch now.
Sitting down, keep this training and you can put your
We will take the lunch and then we will proceed with demo. We have captured the absorption spectra of caffeine here in track number 3. That caffeine is in library. It is showing exact correlation and possible heating. It is showing possible component, heat 1, 2, 3, 4, 5, 6, 7, 8. So first heat is caffeine. So we have already added absorption spectra of many drugs and many components in our library. So if we develop the plate and if we take unknown spectra and if we heat with the library, match with the library, in the library you can see the name of that component, possible heating, possible name. It will be caffeine or theophylline or first 4 में तो 3 caffeine के ही आ रहे हैं and first heating is caffeine and correlation is 0.99 and position is 0.62 RF value. So it is exactly matching with the library. So this is spectrum comparison. There are many absorption spectra here in the library. You can see we have full-fledged library. Then pirozicam, amlodipine, etc. Many drugs, street drugs, poison, pesticides, toxicological compounds we have added in the library. Their absorption spectra.
For example, if the questioned sample
Yes.
is not matching with any of the substance
Spectrum.
available, is it going to upgrade? The library is going to upgrade?
We can add now. We can add the spectrum here. We can add the spectrum in the library. We can create our own library. For unknown samples, if you find out which band it is, you can take the spectra and add in the library. Library upgradation is automatic. Okay. Absorption spectrum library upgradation is automatic. Understood. This is the main feature of for forensic customers. This is very important feature. We have to take the spectra of unknown compound and we have to heat it with the library. Okay. So spectrum library feature. So RF value, color under different illumination, before and after derivatization and absorption spectra. All these are confirmation points whether this compound is detected or not. Okay. Yes, I think I tried to explain you in shorter way, but within few days, if you have system in your hand, you will learn this after running 2-3 plates immediately. सिर्फ प्लेट को हैंडल करना है वन मॉड्यूल से अदर मॉड्यूल और एग्जैक्टली पोजीशन पे रखना है. बाकी सिस्टम इज ऑटोमेटिक इफ यू हैव ATS4 स्कैनर विजुअलाइजर एंड TTC चैम्बर, नथिंग एल्स. Some practical experience is also required if you
What kind of combo
develop
do you recommend for academics like this?
compounds in this for demo.
Any combo kind of a
Combo,
make
okay.
Which machine
Okay.
and components of the machine.
Means if you have all, then it will be better. All
that's
means
okay.
applicator is must applicator. Then development के लिए twin top chambers are okay. And then photo documentation with visualizer and scanner. These are main important. Along with this, our software ultimate vision cats and
अलग
WinCat
अलग
software.
रेट होता है वो सॉफ्टवेयर एक अलग अलग रेट.
Yes, yes. इसका सभी का कोटेशन वगैरह वो सभी included in one single quotation. All this. Sir will provide. I will ask sir to come join. Thank you, sir, again. Okay.
Ultimately that is the thing. You know.
Yes, yes, yes. मैं उनको ही बुला था वो भी. Yes.
Good.
Thank you. Something remaining or something, I request you to please subscribe our channel Anchrom, because in shorter time I tried to give you higher dose. मतलब वो booster रहता है उस टाइप का. But ठीक है. But it is not like कि one day में कोई भी ट्रेनिंग नहीं
Overall
होता.
idea
But
तो अगर
overall एक
कोई-
जनरल आइडिया कि HPTLC का यूज क्या है, एप्लीकेशंस क्या है एंड एग्जैक्टली फॉरेंसिक के हिसाब से उसे कैसे डाला जा सकता है. तो वी कैन यूटिलाइज इन मेनी वेज. Plate is in your hand. If something goes wrong, discard the plate. Do it again. It is very cost effective. ऐसा नहीं. कॉलम आपको कॉन्टामिनेट किया आपने HPLC का तो वो 50,000 1 लाख का आता है. तो वो डिस्कार्ड करना इज डिफिकल्ट. बट प्लेट है, आप कभी भी उसको डिस्कार्ड करके दूसरा प्लेट लेके एनालिसिस स्टार्ट कर सकते. दैट इज द वे फॉर R&D. Yes. 1 minute. I will come.
Tell it. What of thanks?
Any one of you after that. Huh?
Who has prepared? Swati. हाँ स्वाति. स्वाति किधर है?
तो इसके लिए प्रिकॉशन क्या लेना होता है. ये सिलिका है, ठीक है. तो जब भी आप थोड़ा भी हाथ लगाओगे तो सिलिका आपके हाथ में आ जाता है, ठीक है. तो पहले तो जब भी आप प्लेट हैंडल करते हो वेयर ग्लव्स, और आपको विदाउट ग्लव्स भी अगर हैंडल करना है तो यू शुड ऑलवेज हैंडल द प्लेट एजेस के ऊपर, ठीक है. सो अभी ये प्लेट है तो आपको ये सिर्फ इंसर्ट कर एंड देन you have to just attach the scale and lock the stage. Okay. So आपने प्रेजेंटेशन में देखा रहेगा सैम्पल प्रिपरेशन 100 mg या फिर 10 mg जो भी आपकी रिक्वायरमेंट है. आपका पूरा प्रोसीजर होने के बाद जो आपको सुपरनेटेंट मिलेगा वो आप वायल्स में डालोगे, ठीक है. वायल्स में डालने के बाद आपका सैम्पल और आपका स्टैंडर्ड या फिर आपके सिर्फ सैम्पल रहेंगे तो आप वो कौन से पोजीशन पे रखोगे ये आपको सॉफ्टवेयर से कमांड देना है. सो उस जगह पे आपको आपके वायल्स रखने हैं और सॉफ्टवेयर से कमांड देना है, ठीक है. तो ये जब भी हम लोग डेमो देखेंगे तभी आप वर्किंग कंडीशन देखोगे कि कैसे रन होता है. तो यहाँ पे क्या होता है कि यू कैन सी देयर आर 2 डिफरेंट बॉटल्स, ओके, मिथेनॉल एंड वेस्ट बॉटल. सो जो
नीचे झुक के देखना है.
या यू कैन
एक वॉश बॉटल है.
यस वॉश बॉटल है और एक है सॉल्वेंट. तो अगर आपका सॉल्वेंट इथेनॉल है या फिर जो भी आपका वाटर है तो आप वहाँ पे वाटर रखोगे, विच मीन्स एवरी टाइम अगर आपको अभी इसमें भी जब भी आप सैम्पल एनालिसिस करते हो या फिर सैम्पल एप्लीकेशन के लिए लगाते हो तभी फर्स्ट स्टेप जो ये फॉलो करेंगे दैट इज़ द क्लीनिंग ऑफ द सिरिंज. ओके. सिरिंज क्लीन करने के बाद सैम्पल लेगा वो. सैम्पल होने के बाद इट विल अगेन रिंस द सिरिंज. सो ये सब ऑटोमेटिक होता है. वहाँ पे यू हैव टू मैन्युअली डू एवरीथिंग. यहाँ पे सब स्टेप्स ऑटोमेटिक होते हैं. ओके. सो यहाँ पे फिक्स्ड सिरिंज रहती है. जो ATS के साथ आती है, सर्विस इंजीनियर चेंज भी कर सकते हैं सीरीज, या फिर कभी कुछ डैमेज हो या फिर जो भी हो. सो यहाँ पे टू बॉटल्स है, वन इज वेस्ट एंड वन इज द सॉल्वेंट दैट विल बी रिक्वायरिंग फॉर योर एनालिसिस, एंड नेक्स्ट इज द सीरीज. ओके, सो दिस इज द ऑटोमेटिक ATS 4.
How rugged is the syringe?
Ma'am, like you can use it like what,
कितना लाइफ होता है नॉर्मल एवरेज?
जितना आपका सैंपल मतलब वो सीरीज टूटता नहीं है तब तक यू कैन यूज द सीरीज.
What is the factor that is likely to damage the tap?
आपकी जब इंस्ट्रूमेंट शिफ्ट करते हो या फिर अदरवाइज इट इज, या फिर अगर
करंट
आपका कभी
फ्लक्चुएशन से वैसा होता नहीं, वो
नहीं,
पूछना.
वो सिर्फ आपको ये देखना है कि अगर आपका सैंपल स्टिकी रहा तो एट दैट टाइम यू हैव टू टेक केयर कि, क्योंकि वो अभी स्टिकी रहेगा तो इट विल टेक लॉट ऑफ प्रेशर ड्यूरिंग टेकिंग द सीरिंज. सो तभी देर इज अ चांसेस कि सीरिंज नहीं टूटती, ये जो नीडल दिख रही है आपको इट कैन डैमेज. सो
अगर स्पेयर मिलता है, स्पेयर मिल जाएगा.
हाँ,
कितना होगा अंदाजा?
मैम आई डोंट नॉट हैव एनी आइडिया, ये आपको सर्विस या फिर सेल्स को पूछना.
नहीं, वो क्यों पूछ रहे? बिकॉज दिस रिप्लेसेबल शुड नॉट बी टू कॉस्टली. नो, मोर देन द मिशन है तो वो मिशन फेंको फिर नया खरीदो, वैसा तो
ओके.
नहीं.
सो यू कैन आस्क नायडू सर और ओके. सो नेक्स्ट इज डेवलपमेंट. तो वो चेम्बर वहाँ पे तो फिर मैं सो डेवलपमेंट के लिए आपने चेम्बर देखा रहेगा इन 3 डिफरेंट डायमेंशंस. आपने चेम्बर देखा रहेगा, मैनुअल देखा रहेगा, ऑटोमेटिक देखा रहेगा और मल्टीपल डेवलपमेंट देखा रहेगा. तो फिर आपने वहाँ पे देखा रहेगा कि जो मैनुअल है उसमें देर आर डिफरेंट डिमेंशंस, 20x10, 10x10, 20x20. सो अकॉर्डिंग टू द प्लेट साइज यू विल बी यूजिंग दैट पर्टिकुलर चेम्बर. सो डेवलप होने के बाद आपको जो रिस्पॉन्स मिलेगा उसके लिए आप PLC विजुअलाइजर यूज करोगे. ठीक है,
आजा इस तरफ आ जाओ, दिखता नहीं, आ जाओ.
सो दिस इज L stage guard. ओके,
चलो.
और अकॉर्डिंग टू द प्लेट, some of you can come here. So according to the plate size, अगर आपकी, so you can see there are 3 different triangles, sorry 2 different triangles, और यहाँ पे 3 positions है अलग अलग. So अगर आपकी plate size is of 20x20, तो suppose ये A B C है, तो आपको ये L stage का ऐसे अटैच करना C to C. ओके, अगर आपकी प्लेट साइज इज 20x10, so it will be B to B, and if your plate size is 5x10 or 10x10, तो आप ये ऐसे arrange करो A to A. Why? Because यहाँ पे जो कैमरा है वो अकॉर्डिंगली इमेज ये करेगा, क्योंकि आपकी प्लेट साइज है अकॉर्डिंगली वो इमेज कैप्चर करेगा. ये कैमरा मूव नहीं होगा, आपको फोकस करना है, इसके लिए वो L stage कार्ड दिया है. अकॉर्डिंग टू द रिक्वायरमेंट आप आपकी प्लेट साइज एडजस्ट करोगे.
20x20 सेंटीमीटर.
ठीक है,
25 नंबर.
स्टेप इज स्कैनर. तो स्कैनर में भी आपको बोला रहेगा रेंज इज 190 to 900. अगर आपके कंपोनेंट्स यूवी एक्टिव है तो ये आपको कैसे समझेंगे, जब भी आप डिटेक्शन मॉडल PLC विजुअलाइजर यूज़ करोगे तो तभी आपको समझेगा कि वेदर योर कंपाउंड्स आर यूवी एक्टिव और फ्लोरेसेंस एक्टिव. तो उस वेवलेंथ पे आप पर्टिकुलर स्कैन करोगे. तो ये कमांड भी आपको सॉफ्टवेयर से है. तो लोड बटन दबाने के बाद स्टेज विल कम इनसाइड. यू हैव टू प्लेस keep the plate inside, or you have to lock this with a magnetic stick. Once you have kept your plate, again click on load button and close the scanner, and you have to give the command from the software continue. So वो जो particular wavelength है उस पे वो स्कैन करेगा. ओके, फिर आपने देखा रहेगा डेरिवेटाइजेशन. सम कंपाउंड्स आर नॉट ईदर यूवी एक्टिव और फ्लोरोसेंस एक्टिव आफ्टर डेवलपमेंट. सो देर इज अ नीड टू गिव अ पर्टिकुलर क्रोमोजेनिक ग्रुप टू दैट कंपोनेंट. तो उसको हम लोग बोलते हैं डेरिवेटाइजेशन स्टेप. सो यहाँ पे व्हाट यू डू, आप एक क्रोमोजेनिक ग्रुप मतलब डिप करते हो. सो उसमें भी आपने देखा रहेगा कि देर आर अगेन 2 मॉड्यूल्स. एक है डिप. तो डिप में आप क्या करते हैं, 200 ml ऑफ आपका जो रिएजेंट रहता है वो आप डालते हो वो चेम्बर में और डायरेक्टली 5 सेकेंड्स के लिए आप डिप करते हो. और नेक्स्ट जो है ऑटोमेटिक है. दिस इज द डेरिवेटाइजर. ओके, तो ये डेरिवेटाइजर जो है इट कम्स विथ 4 डिफरेंट नोजल्स अकॉर्डिंग टू द विस्कोसिटी ऑफ द रिएजेंट दैट यू यूज. तो उस हिसाब से ये नोजल्स बने. ठीक है। तो जो भी आपका, तो इसके साथ अगेन देयर इज वन शार्ट। सो वहाँ पे दे हैव मेंशन कि अगर आप एक पर्टिकुलर रिएजेंट यूज़ कर रहे हो तो what should be the nozzle that you should be using or at which spray level. So you can see there are 6 different spray levels.
हो गया
So the according to
वाले हो गए ये
chart
रहे
follow
ये पहले
करने
से
के
सुनना
बाद you can see
ये
मेरा
वाला लास्ट में आएगा
advertising division है। तो मैं कौन सा नोजल यूज करूँगी, कौन सी स्पीड पे स्प्रे करूँगी, ये सब चीज़ें ठीक है। तो यहाँ पे दिस इज दी हुड। सो यहाँ पे आपको पहले फिल्टर पेपर प्लेस करना रहता है और बाद में आपकी प्लेट आएगी। प्लेट आने के बाद एडवर्टाइजिंग रिएजेंट इसके अंदर डालोगे और फिर
आई डोंट रिमेंबर लॉन्ग बैक नो आई डोंट रिमेंबर।
अगर और जो नोजल है
कार्ड दिया
हमारा कार्ड भी नया बना है also have my
सो आपकी
हमारा वो खाली वो ही दिखा था हम बन गए अभी इच्छा के इसलिए भी ले लीजिए।
सो सपोज आपका डेरिवेटाइजिंग रिएजेंट अंदर है और आपकी प्लेट भी अंदर है और आपको भी स्प्रे करना है।
going to be this is because we have started MSc, these are all MSc students, so there is no way that we can shift
अभी परमानेंट
डेरिवेटाइजिंग रिएजेंट जो
so we may add some more courses next year, probably integrated भी add करना चाहते BSc MSc.
तो इसके बाद हीटिंग है, आपने
That's-
देखा रहेगा
I have kept it here also so that I don't want
तो वहाँ पे
नाम भूल गया आपका
तो अभी ये है
avocado
अगर आपके होने के बाद
अगर बेटा पापा
तो और ये
ये ट्रांसफर
ये కనబడట్లేదు కదా నీకు బట్టి
సార్ సార్ పగిలిపోతుంది ఆల్రెడీ ఇప్పుడు లూజ్ అయిపోయింది ఇప్పుడు నువ్వే అంతా నువ్వు నువ్వు ఈ ప్రోగ్రామ్ ఇది
extract that component. So in that case क्या कर सकते हैं?
నీదే మిషన్ నువ్వే చూసుకోవాలి సరిగ్గా చూసుకోవాలి నీకే लास्ट टाइम
Okay, ma'am, sir.
हाँ प्लीज और सेकंड बैच उधर जाना ना
नहीं वो दोनों का सिमिलर एक्सप्लेनेशन जस्ट रिव्यू था।
हाँ, ठीक है।
उसके बाद हम एक्चुअल स्टार्ट करेंगे।
ओके ओके ओके
अभी लंच के लिए प्रोसीड
ओ यस కెమిస్ట్రీ డిస్క్రీట్ అనాలిసిస్ మిగతా కూడా ఉన్నాయి
చూడు అడుగు అతను అడుగు చెప్తాడు
ఇస్ దేర్ ఎనీ అదర్ మిషన్ యూ హ్యావ్ NIR स्पेक्ट्रोमीटर
हाँ एक्चुअली मैम NIR वो भी एग्जीबिशन में गया है। करंटली वी हैव वाटर टेस्टिंग के लिए ये फ्यूचर कंटिन्यूस फ्लो एनालिसिस और एक है वेट केमिस्ट्री एनालिसिस स्मार्ट केम, वो भी दिल्ली वाटर वीक है ना, वहाँ गया है। दिल्ली वाटर वीक में एग्जीबिशन में लगा। दिस इज HPTLC Pro एक्चुअली completely automatic.
that's what you are
yes 5 plates at a time you can keep.
इसका कितना होगा
Costing wise
This is not full system basically right now. We have only fresh storage tank, applicator and development sheet.
It's not like modular, everything in one.
Yeah, this is a modular only, but it's connected between the
this is conveyor belt type of assembly.
It's a conveyor belt.
And ma'am, this is mainly for QC lab and bigger lab where methods are well set. High sample throughput की ये मेथड है, ये इतने बैच टू बैच कंसिस्टेंसी चेक करना है।
Constant काम जो होता है वो
yes for R&D it is of no that much beneficial है। R&D के लिए हाई सैंपल थ्रूपुट से मतलब नहीं है, फिक्स मेथड भी नहीं है कुछ भी। हर एक बार सैंपल सॉल्वेंट बदलना तो इट इज टाइम कंज्यूमिंग, इट विल टेक टाइम। But this is latest technology, means if you see Camag का possibilities, so Camag is always upgrading. तो ये कुछ नया innovative है without any manual intervention. अभी now they will change this scenario to R&D also in future. For botanical they have already changed, but for forensics also they are upgrading a lot. अभी latest जो दिखाया मैंने नर्व्स एजेंट का केमिकल वॉरफेयर के लिए जो यूज करते हैं एजेंट्स, उसके लिए उन्होंने अपग्रेड किया है. So they will adapt that into Pro also in now future upcoming future. But अभी वो नहीं है, उसका जो मेन डिटेक्टर है उसे बोलते हैं.
तो ये मिनिएचर का भी थोड़ा सोचना R&D में,
Yes,
not many labs have this facility of luxury of having that much space.
Camag is working on the this visualizer. thinking about the nature of this.
Scanner plus visualizer mix.
Yeah.
वैसा हमारे अच्छा काम आएगा हम बोले तो we are in
Hyperspectral
CFSL
imaging.
and we don't have much space. इतना ही छोटा इससे आधा भी होगा हमारा
Right.
तो उसमें रखने के लिए and it should have all the features of a traditional kind of a thing. इसके
Okay.
हाँ will बस
Manjusha madam.
मेरी किसी ఏదైనా బుక్ ఇవ్వలేదు
వాళ్ళు ఇద్దరికి పోలా
మనకి ఇవ్వలా
మనకి ఇచ్చాడు
మేడీస్ అని ఇంకో బుక్ ఇస్తాను నాకు
అదే మన దాంట్లో ఇచ్చాడు
చూడు నువ్వు నాకు చూసినట్లేదు ఇచ్చినట్టు కనబడదు
వీళ్ళిద్దరికి ఇస్తాడు వెళ్తాడు
मैं दीजिए बुक आपकी किट में भी है।
नहीं ये दोनों के लिए नहीं दिया ना ये दोनों के
आपको वो दे दूंगा मैम बाहर है।
नहीं वो है
लिए 2-3 कॉपी जरा दे देना
यस
they are the ones you know they have to
So
teach also
we'll go for robotic HPTL.
हाँ ये है मशीन बढ़िया ये
So this is the complete HPTLC system which is handled robotically. तो जो आपको एनालिसिस के बाद आपको प्लेट रखनी होती है तो यहाँ पे फिर आपको एप्लीकेशन के लिए डालनी होती है फिर डेवलपमेंट तो यहाँ पे क्या होता है एक ही बार में आपकी क्लीन प्लेट है जहाँ पे आपने सैंपल्स अप्लाई नहीं की है दैट यू विल कीप हियर ओके सो थ्रू दी बिल्ड कन्वेयर फ्रॉम दिस एप्लीकेशन मॉड्यूल टू अनदर एप्लीकेशन मॉड्यूल इट विल मूव ओके सो अगर मेरी प्लेट क्लीन प्लेट है जहाँ पे सैंपल्स आर नॉट बीन अप्लाइड सो विद द हेल्प ऑफ द कन्वेयर बेल्ट फ्रॉम एप्लीकेशन मॉड्यूल योर प्लेट स्टोरेज मॉड्यूल योर प्लेट विल गो टू एप्लीकेशन मॉड्यूल ओके एप्लीकेशन होने के जाने के बाद सो इट विल अप्लाई द सैंपल्स ऑन टू द प्लेट जो भी आप सॉफ्टवेयर से कमांड दोगे वंस एप्लीकेशन इज डन फ्रॉम एप्लीकेशन मॉड्यूल इट विल गो टू डेवलपमेंट मॉड्यूल सो यार दिस इज़ अ टेफ्लॉन चेम्बर तो ये ओपन होता है और यहाँ पे आपकी प्लेट अंदर जाती है फॉर डेवलपमेंट अभी जो बाकी के सिस्टम्स है उसमें आप एल्यूमिनियम प्लेट यूज़ करते हो बट यहाँ पे यू विल ओनली यूज़ ग्लास प्लेट्स ओके फिर आपका एप्लीकेशन हुआ डेवलपमेंट के बाद विद दिस कन्वेयर बेल्ट इट विल अगेन कम टू दी plate storage module which is the processed module so therefore there are two terms clean and processed so from clean plate your plate will go for application followed by development and once both the steps are done it will come to the processed plates and then you with the help of the software you can remove that plate so this is how robotic HPTLC is so abhi yahan pe there are again 3 different modules they are yet to come so वो YouTube पे अपलोड हो जाएगा सो अभी आप ब्रेक कर लो फिर विल सी द एक्चुअल डेमो पार्ट
वो हम देंगे आपको अभी रेडी है ना
नहीं थोड़ा हमारा
सर्टिफिकेट्स आहेत ना
हमारी तरफ से मैडम कुछ बात करें
ओके ओके
कम
अभिषेक फोटो घ्या ना 2-4 तिकडून
या कम पहले साहब को नमस्कार करें
अरे नहीं राहू दे यहाँ से वी आर ऑन सेम बोट ऐसा नहीं है मैं 6 साल से यही कर रहा हूँ इसलिए मुझे ज़्यादा आ रहा है थोड़ा सा आपको भी अगर 6 साल किया तो मुझसे ज़्यादा आएगा
या स्टार्ट
Good evening, everyone. On behalf of the entire staff and students of the National Forensic Sciences University Pune campus, I, Swati Lakshmi B, myself an MSc first year student, I would like to extend heartfelt gratitude for inviting us to your esteemed company Anchrom for an industrial visit. The opportunity to observe your operations firsthand was an invaluable experience for us. We gained significant insights into the complete working and practical applications of Hptlc, and its significance in forensic science and other fields like medicine, herbal industry, food industry, etc., which greatly enhanced our understanding. Arrangement of the lab tour even before entering the lab for practical experience gave us a general overview of the lab. It was very beneficial for us. The practical session was highly beneficial as we got to watch and learn the complete working process of Hptlc. On the whole, the entire day was very knowledgeable, highly detailed, and informative. Your team's warm hospitality and willingness to share the knowledge made the visit both educational and enjoyable. We truly appreciate the time and effort taken to arrange such an insightful experience. We look forward to the possibility of future collaborations and learning opportunities. I thank you once again for this wonderful opportunity.
Yeah, thank you. Thank you NFSU Pune for accepting our invitation and coming here long the way from Pune. Thank you so much for your time and patient learning and listening.